Hello, this is Mr. Blag, and today we will be discussing writing equations of lines and graphing lines. Okay, we'll discuss the three types of equations of lines: the slope-intercept form, the point-slope form, and the standard form of a line. And then we'll go on to discuss parallel and perpendicular lines and how those lines, their slopes relate to each other. Okay, so let's go ahead and get started. Okay, you know from algebra that there are three different ways to write an equation of a line. You have y equals mx plus b, okay, which is the slope-intercept form, the point-slope form, and then the standard form of an equation of a line. Okay, for y equals mx plus b, m is the slope, b is the y-intercept. Okay, for point-slope form, you have y minus y1, where y1 is the y value, okay, from a point on your line. Okay, m, okay, is the slope of your line again, times x minus x1, where x1 is the x-coordinate from that same point that you chose from your line. Okay, and then the standard form of the line has the x term and the y term on the same side of the equation, okay, and then a constant numerical term on the other side. And in fact, there are some rules for standard equations. I'll show you standard equations of lines. Ideally, by convention, you don't want to have a negative coefficient for the x term, and you don't want fractions. Okay, but you'll see both of those in different people's standard equations of lines. So it just depends on who you are. All right, so let's go ahead and get started. So this video is not too long. It says write the slope of the equation in slope-intercept form. Write the following equation in slope-intercept form, then graph. It says 5x minus 4y equals 8. It's currently in standard form, so we're just going to rearrange this equation solving for y alone. Okay, so I'm going to subtract 5 from both sides of this equation. I'm going to get negative 4y equals, and I'm going to put negative 5x in front, plus 8. Okay, now I'm going to go ahead and divide both sides by negative 4. Okay, I'm going to get y equals negative 5x over negative 4 is going to be 5/4 x. Okay, and what is 8 over negative 4? That's negative 2. Okay, so let me zoom in a little. All right, so this is the equation of this line in slope-intercept form. So all we have to do now is go to our graph. We know that slope-intercept form, this coefficient in front of the x is our slope, and this numerical term over here is our y-intercept. So let's start there. Let's go to the y-intercept of negative 2, okay? And then we're just going to count rise over run. Rise was the top and run was the bottom of that fraction, okay? So I'm just going to say we're going to go up 5 units in the positive direction, 2, 3, 4, 5, and 4 units over to the right in the positive direction as well. 1, 2, 3, 4, okay? And you could do that again, 1, 2, 3, 4, 5, 1, 2, 3, 4. And the same way you could go down and do 1, 2, 3, 4, 5, 1, 2, 3, 4. Why can you go down? Well, going from this point back up to that is technically up 5 and over 5. But the reality is if you went down 5, that's negative 5 in the y direction, and you went over to the left 4 in the x direction, a negative 5 over a negative 4, the negatives cancel out and you're still left with 5/4. All right, so we get a line looking something like this. Okay, and if you want, you could even give coordinates for any major points on your graph, like the y-intercept. Okay, you could say it's at 0, -2. You could say the x-intercept appears to be at, well, do we know? Okay, is it at an exact point? Okay, you get to decide. All right, let's continue. I want you to pause the video. You will not have to graph this one, but I want you to write this equation that's currently in standard form. I want you to write the equation for this line in slope-intercept form. Pause the video and come back. All right, so for this one, it appears that we're just going to, what are we going to do? We're going to subtract 7x from both sides. Okay, I get negative 3y equals negative 7x plus 18. Divide both sides by negative 3. I get y equals 7/3 x. Okay, what is 18 divided by negative 3? That's a negative 6. There's your answer. Easy peasy. Let's go on. Okay. It says write the following equation in standard form. So now we've been given the equation of a line in slope-intercept form. Okay. To write the equation in standard form, you first need to get the x and y terms on the same side. So I'm going to go ahead and subtract 5/7 x from both sides of this equation. I'm left with, okay, you could say y minus negative 5/7 or y minus 5/7 x, but I'm actually going to tack this new term that I've introduced to the left side of the equation. I'm going to tack it on the front, okay, and the reason for that is standard form of the equation is ax plus by equals c. So by convention, we have the x term in front, okay? So I'm going to say negative 5/7 x, okay, plus y is equal to 6. Okay. Now, okay, one of the rules, like I said, or two of the rules for standard form of equations of lines, okay, I don't like there to be negatives in the front, and I don't like fractions. Okay, so I could sweep through in one fell swoop and multiply both of the sides of this equation by negative 7/5. Okay, that will get rid of the negative in the front and this fraction. No, it won't. I'm going to want to multiply by negative 7 would work. That makes more sense. Okay, if you don't believe me, let's take a look at why. Okay, if I multiply both sides of this equation by negative 7, okay, when I just use the distributive property right here, what do I get when I multiply negative 7 times negative 5/7? Okay, the 7's cancel out and the negative cancels out. I'm just left with 5x. Okay. Now, what is negative 7 times y? That's negative 7y. Okay. And what is 6 times negative 7? Okay. It's going to be a negative value. And what is 6 times 7? Okay, 42. So we're going to get negative 42. All right, so now I have it in standard form. Now, the thing is, standard form is not exactly the easiest way to get an equation of a line and graph it. Okay, you could use the intercept method, but I'm actually going to go back now that I've converted to standard form and just use my slope-intercept form that I had. So I'm going to go to positive 6, 1, 2, 3, 4, 5, 6 on the y-axis. That's my y-intercept. And I'm just going to go up 5, 1, 2, 3, 4, 5, and I'm going over 7, 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to do the same thing down here. For the sake of time, I'm just going to connect these, but I don't want you taking any shortcuts. Okay, I'd want you to graph exactly, or at least have enough points that you would know exactly, or nearly exactly, where that would pass through the x-axis. All right, so this next one I want you to try. Again, you're not going to have to graph, but I want you to pause the video now, and I want you to take this equation, which is currently in slope-intercept form, and I want you to convert it to standard form. All right, so to do this one, all we're going to do is move the x term to the other side of the equation again. Okay, so over here, what do I get? I get negative 2/5 x plus y equals negative 3. In the same way we did the first one, I'm going to multiply both sides by negative and then the denominator, in this case it's 5. So I should get, what is negative 5 times negative 2/5? Okay, the 5's cancel out and the negative cancels out, so I should just get 2x. And what is negative 5 times y? That's negative 5y. And what is negative 3 times negative 5? That's positive 15. And I have converted this to standard form, following my rules. All right, so we're about 9 minutes into the video. I'm probably going to go for about 12 or 13 minutes. Okay, I want to make these videos as short as possible for you, but I still want to give you maximal amount of information. So let's go ahead and write the point slope form of an equation for the line that passes through this point with the slope of negative 9. Okay, so if we go to the formula, it's y minus y1. So I'm going to say y, where y will stay a variable, minus, what is my y coordinate of this point? It's negative 7, so I'm actually going to say minus 7. Okay, and I'll go ahead, minus negative 7, okay, equals m, which the slope is negative 9, times x, where x will remain a variable, minus, what's the x coordinate from this point? It's negative 3. Okay, so I'm just going to use some embedded parentheses to help me kind of keep my thoughts straight. Well, y minus a negative 7 is actually y plus 7. Okay. Negative 9 times x minus a negative 3 is actually x plus 3. I'm sorry for my handwriting, but at that point you have officially given the point, or given that equation of that line that goes through that point with that particular slope in point-slope form. Point-slope form is kind of the easiest one to do. Okay. Now I want you to try one. I want you to write this equation. I want you to write it in slope-intercept form. So you're going to use the skills I just showed you and remind you about to actually go in reverse. Okay. So let's go ahead and look at the equation for the formula of a point-slope formula for the line. Okay. And it looks like if the original formula has a negative in it, then when I see that negative right there, okay, I'm going to go ahead and say my y1 is just the 5. So y1 is 5. My slope is 4/3. And it looks like my x1 is 3. Okay, so I would say I could go ahead and use all this stuff, okay, to go find the slope-intercept form of a line. But in fact, another thing I could do is just simplify the whole equation, okay, and get it to look like a slope-intercept form of equation, okay? So all we'll do is distribute on the right side. I'm going to get y minus 5 equals 4/3 x, okay? And 4/3 times negative 3 is just going to be minus 4, okay? Now we're going to go ahead and add 5. I should get y equals 4/3 x. Okay, what is negative 4 plus 5? This should be plus 1. All right. We're moving right along. Okay, it says find the slope of a line that passes through the pair of points 2, -8, and -1, -8. All right, so what we have to do first is when we're just given 2 points and we're looking for the slope of the line, okay? All you have to do here, okay, if we're not looking for the equation of the line that goes through these, it's one step. You're going to do the slope equation is y2 minus y1 over x2 minus x1. It doesn't matter which point you call x1, y1, x2, y2, but just keep the point straight once you start designating certain values. So I'm going to go ahead and go to the second one, and I'll call this x2, y2. I'll call this x1, y1. So if I follow that format, I'm going to say my slope is -8 minus a -8 over -1 minus 2, which becomes -8 plus 8 is 0 over, it doesn't matter what's on the bottom, well, unless it was 0. In this case, it's -3. So my slope for the equation of this line is 0. And sure enough, if you look at the 2 points, okay, they both had a y value of -8. So if we're looking at a graph, okay, if 2 points on the line both had the y value down here at -8, somewhere down here, okay, then that's technically a horizontal line. And sure enough, horizontal lines have a slope of 0. Okay. I want you now to find the slope of the line that passes through the pair of points. Okay, so these are the points. Okay, go ahead and try that now. Okay, I'm not going to answer this for the sake of time. Okay, if you have any questions with that, you feel free to reach out to me or your teacher. But you should be able to find the slope of the line that passes through those points.